Hello everyone, I am Quincy Jane Sainingaska, and for today's video, I will be showing to you the different types of metal can defects, and each defects has a corresponding categories. So we have metal plate manufacturing defects, coating application defects, can body manufacturing defects, can end manufacturing defects, double seam defects, other manufacturing defects, and handling defects. So to thoroughly understand these defects, I will expand each categories with its examples. First is laminated plate under metal plate manufacturing defects. So a laminated plate is a serious defect found in metal plates, especially those used for making cans or container ends. This defect occurs when the plate contains internal layers or folds that were not properly banded during the manufacturing process. As a result, the metal plate can split into two or more thin layers. So this separation happens because during rolling at the steel mill, multiple folds or layers of metal may accidentally get pressed together into a single plate thickness. However, instead of fusing into a solid piece, these layers remain unbanded internally. So later on, when the plate is further processed, such as during stamping or forming in can manufacturing, these weak internal layers may peel apart or delaminate. Another one is pinhole. So it is classified as a serious defect in metal plates used for can manufacturing. It appears as a small, often irregular hole that may range in size from barely visible to more noticeable openings with rough or jagged edges. So these holes are typically formed during the rolling process at the mill. So the primary cause of pinholes is the presence of foreign particles such as dirt, slag, or other contaminants that become embedded in the plate during rolling. These particles do not bond with the surrounding metal. If the particle is large, it can penetrate through both sides of the plate. So during later stages of processing, such as can forming or high-pressure heat treatment or retorting, these embedded particles can dislodge and fall out. This leaves behind a cavity or pinhole in the metal, which can weaken the structural integrity of the can and potentially lead to leaks or contamination of the contents. Next is coater drip under coating application defects. So it is a defect that occurs during the coating process of metal plates used in can manufacturing. It appears as a small drop or splash of coating either on the interior or exterior surface of the plate, and often looks like a tiny, hard bubble or blister of dried coating material. So in some cases, it may resemble a scrap in dye defect due to its shape and raised appearance. So this defect is generally classified as minor unless further inspection reveals a hole in the coating or corrosion on the metal plate underneath. In such cases, the coater drip is considered a serious defect as it can compromise the integrity of the can and pose a risk of contamination. Commonly, coater drips are caused by accidental drips or splashes of coating material during the application process in the coating line. So these defects require careful evaluation, including opening the can or removing the drip to determine whether the underlying metal has been compromised. So another one is coating skip. So these are areas on a metal plate where the protective coating has not been properly applied, so resulting in bare or thinly coated spots. So these discontinuities can appear as small bare patches, fine lines, or hairline skips, or holes in the coating layer or eye holing. If left unaddressed, these exposed areas can lead to metal corrosion or chemical reactions with the product inside the can, such as sulfide staining. So coating skips are classified based on their severity and location. Serious defects if they occur internally with corrosive contents or externally and show plate corrosion. Minor defects if they occur externally without corrosion or internally with non-corrosive contents. Some common causes include contamination of the metal plate surface with dirt, grease, or other residues before coating. Next is errors during the coating process such as uneven or incomplete application. Second is errors during the coating process such as uneven or incomplete application. Acid salts corrosion in can body manufacturing defects. So it is a serious defect found in 3-piece cans. It typically appears as rust on the outside of the side beam or as visible salt deposits inside the can. This issue arises when acidic residues, often from the soldering process, remain on the can surface. These residues usually come from acid crystals added to the solder bath to keep the solder rule clean and well tinned. If not properly rinsed or neutralized, the acids can trigger corrosion over time, compromising the can's integrity and potentially affect the product inside. So proper cleaning and maintenance during the soldering process are essential to prevent this defect. Another one is cold solder in can body manufacturing defect. So it is a serious defect in three-piece cans that occurs when the solder used to seal the side seam does not properly bond. This results in gaps, voids, or a rough, spongy appearance in the solder fillet, which can create a potential leakage path through the side seam. This defect is most likely to appear at the ends of the side seam, known as the lap area. However, detecting it accurately often requires tearing down the can's side seam and double seam for close inspection. So the primary cause of cold solder is solder that is applied at too low a temperature, preventing it from flowing and bonding effectively to the metal surfaces. Next is double end under can end manufacturing defect. Double end is a serious defect where two can ends are mistakenly seamed onto a single end of the can body. This results in a visibly thicker and longer seam that may show irregularities such as drops or V-shapes along the double seam. This issue commonly happens when two end plates stick together before entering the end piece. These stacked plates are then curled as one, but only the inner one receives the sealing compound. In other cases, two or already formed ends may accidentally be seamed together onto a can body, leading to the same defect. Double ends can compromise the seal integrity and may affect the can's appearance and performance during processing or storage. Other one is scrap in die marks in can end manufacturing defect. So scrap in die marks are abnormal impressions or marks left on the metal plate during the manufacturing process, which can vary in size, shape, and depth. These marks can be classified as serious defects if they cause significant issues such as fracturing of the metal plate, sharp, angular, or deep impressions that could lead to fractures during handling, exposure of the metal by breaking through the inner coating potentially causing reactions with the product inside the can, or problems with the formation of the flange which could affect the can's sealing integrity. On the other hand, scrap in die marks may be considered minor if they are smooth, round, and shallow, without impacting the functionality or appearance of the can. These defects can potentially lead to further issues in the can's sealing process, especially if they affect the formation of the curl or double seam. Next is broken chuck under double seam defect. So, a broken chuck is a serious defect in the double seam of a can as it results in a loss of tightness at the point of the defect, compromising the seal. This defect occurs when a portion of the double seam is not properly formed due to a void in the chuck lip, a part of the can seaming equipment that fails to apply adequate pressure. The defect manifests as an irregularity on the countersink wall of the seam, where the seam should be smooth and uniform. The common sources of this broken chuck is cheap seaming chuck, which can be caused by a jam up or improper setup of the equipment during the seaming process. So this defect can lead to weak seals, potentially causing leakage or failure to properly seal the can, making it a critical issue in can manufacturing. So cut down flange under in double seam defects. So it is a serious defect in the seam of can, primarily due to the absence of proper overlap between the body flange and the can end. So this defect occurs when a portion of the body flange is torn or cut, with part of the flange being torn back against the can body but not properly engaged with the end hook. The cut portion may protrude below the normal seam. In more severe cases, this can create a hole in the can body just below the double seam, leading to leakage risk. A specific form of this defect, called the index fault, that is found on reformed cans and is characterized by a tear in the flange about 10 to 15 mm from the reform ridge, caused by flange damage during the reforming process. The common sources of this is flange damage during handling of open tap cans. Next is flange damage during filling operations, flange damage caused by other canning line equipment, flange damage from the grip chain during the formation of the can body cylinder, and last is misindexing of collapsed can body planks during the reforming process. So this defect compromises the integrity of the can and can cause leaks or improper sealing, which is why it is considered a serious issue in can manufacturing. So we have this called paneling under in other manufacturing defects. So paneling is a serious defect in container profiles that occurs when the can body experiences permanent distortion, so usually appearing as flat, vertical panels or indentations. This defect is most commonly observed in larger size containers, and it happens when the internal structure of the can is compromised, which can cause issues such as the fracturing of the internal coating or distortion of the double seam or side seam. So paneling significantly affects the can's structural integrity and can lead to further defects during processing. So the common sources of this is from excessive closure vacuum, too much vacuum pressure when sealing the can, and excessive external pressure when high external pressure applied during the processing stages, and excessive pressure during cooling, so when pressure applied to the can during the cooling phase, and inadequate plate gauge or temper when weak or improperly tempered metal used in the can body construction. So this defect can compromise the can's overall functionality, making it less resistant to external stresses. Another one is peak can defect. So under in container profile defect or other manufacturing defects. So peak can is a serious defect characterized by a permanent outward distortion of the can end, resembling a pyramidal shape near the double seams. So this distortion results from a significant difference between the internal and external pressures of the container. When the pressure imbalance is severe, it can cause the metal plate or coating to fracture and can distort the double seam, compromising the can's structural integrity. Excessive peaking can weaken the can and make it more prone to failure during handling or further processing. So this defect is also referred to as buckling or a buckled end. So the common sources of this peak can is from insufficient closure vacuum when lack of proper vacuum pressure during the sealing process, and insufficient external pressure during cooling when inadequate pressure applied while cooling the can, incipient spoilage before processing, when early spoilage causing loss of vacuum before canning, an inadequate plate gauge or temper, using weak or improperly tempered metal for the can ends, and overfilling of the can when filling the can with too much product with causing pressure buildup. So this peaking not only affects the appearance but also compromises the effectiveness of the seal and the overall durability of the can, so increasing the risk of leakage or contamination. So abrasion defect under in handling defects. So abrasion is a serious defect that occurs when the metal plate of a can is worn down mechanically, often leading to a reduction of thickness by more than 50%. This wear and tear weakens the metal, making the affected area more vulnerable to fracture or corrosion. If left unaddressed, abrasion can result in perforation of the metal plate, compromising the integrity of the can. So the common sources of this is moving cables or metal conveyors. So
when abrasion can occur when cans are moved along conveyors that rub against them, whether they are empty or filled. So, another thing is contact with stationary objects with sharp parts. So, can may experience abrasion if they are moved against rough or damaged surfaces such as when they are loaded into baskets with sharp edges or rust.
Another one is chalky side seam under in handling defects. So, chalky side seam is a minor defect characterized by the appearance of white chalky deposits or mild corrosion on the shoulder of the side seam. So, this condition is usually not severe and is unlikely to develop into more serious rusting or degradation of the can. So, the common sources of this is from alkaline boiler water carryover. So, water with a pH in the range of 8 to 9 may cause chalky deposits on the side seam. So next is green or wet pallet boards. So wet or damp pallet boards may introduce moisture that leads to chalky deposits. Third is salt air exposure or high humidity. So environmental factors such as exposure to salty air or high humidity levels can contribute to this condition. Last is extended storage in unfavorable conditions. Storing cans for a prolonged period under poor environmental conditions may lead to the development of chalky deposits.